We're starting chapter 5, section 5 here, and practicing the greatest common factor. Just so you know, I'm not terrible at writing, just this. Anyway, there's a lot of different ways of finding the greatest common factor. I just want to give you a heads up. I'm a big fan of one method, but just so you know, if you were to Google the greatest common factor, you might find several different ways of finding it. Most textbooks will go with the explanation of doing factor trees. And what's nice about factor trees is you really can do this with really easy numbers. Like you can divide every one of these whole numbers by 2. And because, and maybe I should have mentioned, GCF stands for greatest common factor, is we're looking for all the common things that go into it. So 2 times what gives me 32? You can use a calculator. 32 divided by 2 is 16. 48 divided by 2 is 24. 24 divided by 2 is 12. Actually, from this point on, whatever you did for this, you could probably do again for the 24. Like, 2 and 6, 2 and 6. I'm getting a little ahead of myself though, because this is 2 and 8. This is 2 and 4. This is 2 and 2. And this is 2 and 3. And this is 2 and 3. All right. So just breaking it down with primes. This is not the only factor tree, but we only care about the bottom of the trees. So we look at the bottom. In other words, we're looking at the prime numbers. Okay, just a reminder what a prime number is that only factors of prime numbers are 1 and the number itself. I was looking at 2. 2 is the first prime because the 1's technically not prime. But anyway, what I like to do is look at the bottom of the trees and rewrite it as 2 to the 5th power because there's 5 of them. And we ignore all of these composite numbers. So we also have x to the 4th, y squared. And then here we have 2 to the 4th times 3, so that 3, and then x cubed y. And then this one is 2 to the 3rd, then the 3, and then it just says y squared. So how do we figure out what the greatest common factor is? Is I like to go through and just maybe circle, maybe underline, I don't really know, the common terms. You see how each one of these has a 2? And let's see, this has an x. This one has a 3 and an x. This has a 3 and a y. Okay, so neither 3 or x are in common, but every one of them has a y as well. And what you want to do is, maybe I'll just say, I don't always underline, but underline the common things or identify them. Sometimes I circle them. And what we want is the smallest exponent of the common ones. So as I look at 2 to the 5th, to the 4th, and to the 3rd is the smallest exponent. And then as I look at my y's, so y to the 2nd, to the 1st, or to the 2nd, to the 1st is the smallest. So in other words, the greatest common factor, 2 to the 3rd power is 8, 2 times 2 times 2, y, is the biggest value that goes into all 3 of these numbers. Okay, I hope you agree that 8 is the biggest number because, 16 goes into 32, but 16 does not go into 24. Let's see, what would be another one? 12 goes into 24 and 48, but 12 does not go into 32. So 8 is the biggest number, and then x does not go into all 3 of them, but y does. And the biggest value is just y to the 1st. Yeah. So if you didn't like the way I taught it, you can Google other ways. One way that you may have learned in elementary school is just list all the factors, but then you kind of miss out on the other piece of it. So that's the way I like to do it. And why do we learn the greatest common factor? Is so then we can do, factor out by doing the greatest common factor. So as I look at this, and I were to do a factor tree, so 3 times 2 times x squared, 9 is just 3 squared, 15 is 3 times 5. These are all primes, by the way. Maybe this time I'll just circle. The 3 is the only thing that's in common. And what's the smallest exponent? Well, the smallest exponent is either here or here. It's to the first. So what you can do is you can factor out a 3. And then what I didn't circle, and maybe I shouldn't have written this as 3 squared. I could have written this as just 3 times 3. What I didn't circle stays in the parentheses. So 2x squared plus 3 plus 5x. And this is math class, so you can always check your work. You can check your work by distributing. So if I were to ask you to distribute in that 3, it'll go back to the original problem. 3 times 2x squared is 6x squared. 3 times 3 is 9. 3 times 5x is 15x. There you go, we did it right. So as we look at letter B, actually there's nothing common between these things, because 8 is just 2 times 2 times 2. This has an x, this is 3, 3 is not in common, this is all y's. I'm actually fine if you just rewrite this as your answer, or you can say unfactorable or not factorable. There's no GCF, whatever makes sense to you. Okay, and if the back of the book writes something slightly different, then feel free to as well. Another way that I teach this sometimes, let me explain letter C slightly different, because maybe those first two methods didn't work for you, is I actually just write out, 2 times 2 times 2 gives me 8. And then I write out a times a times a times a, because maybe you didn't like how I write down the smallest exponent. But if you circle the way I mentioned earlier, there's a 2 shared between each. There's an a shared between each. There's another a shared. And there's another a shared. So what I'm saying is 2a to the third could be factored out. Now what's left over? Well, instead of writing 2 times 2 times a, you can go ahead and figure out that 2 times 2 is 4a. Now, every year I do this, somebody forgets. You need a quantity here so it holds its spot. Because remember, you can check your work by distributing. If you don't write anything there and you only had 2a cubed times 4a, you wouldn't have anything. So what quantity can you put there to hold its spot? Well, what times 2a cubed would give you 2a cubed? And that answer would be 1. And sometimes what I have students do is when your greatest common factor is the number itself, go ahead and write down times 1 so you don't forget about that quantity. So yeah, here's your answer, and you can check your work by distributing. And the more practice you get, I think the better you'll get, because after a while you'll notice, well, if the greatest common factor, I don't need primes. As long as I can identify, like 8 times 8 gives me 64, and over here 8 times 1 will give me 8. Okay, but you still have some work to do of figuring out, x, x, x. There's 5 of them. There's 2 y's. There's 3 x's here. There's 2 y's. So as you circle the 3 x's in common, the 2 y's in common, you can then identify your answer as 8x cubed y squared times the quantity 8x squared minus 1. And again, you can check your work. But feel free to pause at any point if you need to, try it on your own. Come up with a new problem. Go to the homework. Try a few problems from the homework. So exercise 4. By the way, sometimes what I'll do is I'll also factor out a negative. So I'll just show you. You don't have to factor out a negative, but some people like to have a positive first term. As I'm looking at the numbers, 9, breaks down as 3 and 3. Well, this is already prime, it's not 3. This is already prime, it's not 3. So there's actually nothing common between the numbers. But as you look at, the 4x's, 2y's, 2x's, 2y's, 1x, and 2y's, you can actually see that you could factor out 1x and 2y's between all, oops, I almost circled the wrong thing. So I'm going to factor out a negative xy squared, and what I didn't circle has to stay there. So that would be 3 times 3 is 9x cubed minus 5x minus 7, and we factored out both of those. Let me just highlight it. Here's your answer then. And notice how, because I factored out the negative, it changed the sign of everything inside. And by the way, on the next problem, just to give you a heads up, is I don't know what value x is, but what's shared here is that they're both 4 more than x. So let's say x was 10 for a second. I'm just making up a number. Well, this value is 14. Same thing with this. If x were 10, then that value is 14. So they are shared. They are shared. So I can pull that in front. Notice I'm trying to circle it like I typically do. And then what I didn't circle stays in the other set of parentheses. So I'm looking at 3 plus 5b. And you may have done this before, but maybe you didn't really understand it before. But that's all you need to do for problems like exercise 5. If the parentheses are identical, then you can factor them out like that. I think I have enough time to do at least one more. Yeah, because it's really the same thing. You see how what's inside the parentheses are exactly the same. Maybe I'll highlight them. Let me highlight them. If they're exactly the same, I don't know what the value is, but they're exactly the same, so I can put them together in front. So imagine I circle them for a second. What did I not circle? I did not circle the 8b, and you need a placeholder. You need a quantity right here, and that quantity would be 1 to go over here. So why do we have you understand that before moving on? Is right now there's no greatest common factor in exercise 7. But when there's 4 terms, what you can do, some people call it split the middle. I don't really like that phrase. I like saying you factor by grouping. Because now you can look for the GCF of the first 2 terms. So this is called factor by grouping. And there's an x shared between the first 2 terms. I'm left with y minus 5. Now if you do this correctly, you should have exactly the same thing in the other set of parentheses. Well, we kind of have an issue right now because I want y before. And now I can look at that and say, oh, well 10 can be written as 2 times 5. And then I have a 2 shared between them. So I'll write the 2 in front, and I'm left with y minus 5. And so now what's inside the parenthesis is exactly the same. I can write that in front. I hope this is ringing a bell from last year. And then what is left over, what I did not circle, or underline I guess in this case, is the x and the 2. And that is the final answer. So I'm going to stop the video. I don't know how long the second video will be, but this is your beginning of section 5.